So if we look at the next function that we're interested here is f of x is equal to x squared under the condition that x is less than -1. Okay? And it's x plus 6 under the condition that the number x is greater than or equal to -1. So in this case again, we see the breakpoint being -1. That's where the rule changes. We have two different rules based on the values of the domain. What value you're using. You have two different rules. And piecewise defined functions can have lots and lots of rules. They don't just have to have 2. They can have 3. They can have 4. They can have 10. It's just that as opposed to x being the same for all real numbers or for a certain number of numbers in your domain, the rule is changing for different regions of the domain. Okay? So let's see if we can interpret this. Let's make some charts, because we're going to ultimately want to graph this. And so we're going to put some points on paper. So let's make some charts and see what we can come up with here. Okay. So often when we want to graph, we just make ourselves a little table. I'm going to use the top rule. When am I going to get to use the top rule? I'm only going to get to use the top rule when x values that I pick are less than -1. Okay? Now, I don't want to get too big because I won't be able to put very large negative values on my graph that I'm ultimately going to show you. But let's start with like -3. Okay? If x is -3, this says to use the top rule because it follows this condition, this top rule. When x is less than -1, which -3 is, we should use x squared. So the output for the function here would be 9. Let's try another one. If x is -2, I'm still on the top rule side of the page. Because if x is -2, then I want to square that, and I would get +4. Okay? I wouldn't be able to put -1 in the top rule, though, would I? I can't. Because if I use -1, then I got to go to the bottom rule. So I'm going to go do that one over here. And I'm going to show you something about this. If we use the bottom rule, if x is -1, it goes to the bottom rule. But what if x is -1.5? If x is -1.5, that's still a number that's less than -1. Okay? So if it's less than -1, I can put it over here on my top rule. So -1.5 squared would be 2.25. Okay? What's another number that's close to -1 that's not exactly equal to it? Well, how about -1.1? That's only 1/10 away from -1, but it's still less than -1. So we still use the top rule there. That's very important. We can get really close to -1, as close as we want to, but -1 itself bumps us over to the bottom rule. If x is -1.1 and we square that, we're going to get 1.21 positive value. Now we can get very close to -1, but if we get actually equal to -1, because of the condition of the piecewise defined function, we have to jump over here to -1 on the bottom rule. And when x is -1, the new rule for the bottom says to add x plus 6. So that's 5. Okay? If x is 0, that's a number that's greater than -1. So we still have to go over here to the bottom rule. That's 6. 0 plus 6. If x is 1, now all the other numbers that are greater than -1 are all over here using the bottom rule. 1 plus 6 would be 7. Okay, and one more. Let's go up to +3, and then we'll have 3 is greater than -1. Use the bottom rule. We get an output of 9. Okay? Now, what we want to do is we want to go graph this. And so when I change to the graph that we're going to look at, I'm going to lose the ordered pair. So write those down right now real quick. I'm going to try to remember the ones that we had too. Because we're going to plot these ordered pairs on our graph. so we can see what the graph of this piecewise defined function looks like. Okay, let me go ahead and we'll make our table here now while I'm still thinking of it. So we'll know what values we found so far. For our piecewise defined function given before, and we will write it right here. F of x is equal to x squared if x is strictly less than -1 and it's x plus 5 if, x plus 6 if x is greater than or equal to -1. So what we started with -3, we got +9. We did -2, we got +4. We did -1.5, still using the top rule here, we got 2.25. We used -1.1, we got 1.21. Okay? Then when we got to -1, we had to switch rules. So we got 5, and when we used 0, we got 6. We used 1, we got 7, and when we used 3, we got 9. So there's our ordered pairs that we want to graph on our graph. Let's see how many of them are going to fit. Okay, I'm going to use an integer scale here, so that means that this is going to be 1, 2, 3, 4. There's my big one. That's going to be -5. 1, 2, 3, 4. +5. 1, 2, 3, 4. +5. 1, 2, 3, 4. -5. This is my x-axis. This is my y-axis. And I'm ready to go graph this function. Let's do it in red. Okay. We want to plot the point -3, 9. -3, 9. And it's just barely going to fit. 5, 6, 7, 8, 9. So right here. -3, 9. There's my first point. -2, 4. Right here. -1.5, 2 1/4. So when I'm over -1.5, I'm up 2 1/4 right there. Right there. Okay? And then at -1.1, we found out that f of x value there was 1.21. So just a little bit under 1 1/4. So at really close to -1, but it's on the left-hand side of -1, we're right here. 1.21. 1.21. Right there. Okay? When we get to -1, look where we go. We're here. -1 itself is actually up there at 5. If x is 0, we get 6. If x is 1, we get 7. And when x was 3, we would get back up here to 9. Okay, now, this part here is curvy, because it is a quadratic function. This is where I get to test my abilities here. Now, what we got to do is we got to show some notation. We can use -1.00000000001, something very, very close to -1. If we squared that, we would get an output that's very, 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 very close to +1. So the way that we're going to show that on the graph is we're going to put an open circle here. That's what we have to use to represent the fact that we can get close to -1, but when we actually use -1 itself, the rule changed, and we have to use the top. We have to go back up here to use the bottom rule. -1 plus 6 would give us +5. Okay, now we can keep picking numbers, many numbers less than -1, -4, -5, etc. So I'm going to use the arrow up here to indicate that this goes on forever. Okay. But once we get to -1, we're at +5. And then the remaining part of the graph is a straight line, straight linear graph. What happened here? It's supposed to be linear, so it's supposed to be going through that point. Maybe I can't count. 5, 6, 7, 8, 9. I can't count. Here's the 9 right here. Right here. My apologies. Let's erase that one, and then we'll erase this one, and then we're... Okay, now we'll go back to our red. And then we're there. Okay. And so now we have the graph of this piecewise defined function. Is shown here. That's what we did. We graphed it. It's in 2 branches. And these 2 branches don't meet up. Now, some piecewise defined functions, they can meet up. These don't. And we have a special thing to call that in calculus. Thank you very much. Try some piecewise defined functions in your book now. and tune in later.